Suppose you use calcium and hydrochloric acid to create the hydrogen gas as shown below. Calculate the mass of calcium metal and the volume of 3 molar HCl needed to make 520 milliliters of hydrogen gas. So assume you're collecting the gas under normal classroom conditions, similar to what we did in the volume is right. So the first thing that I'm going to do is to calculate the mass of calcium metal. So the first thing that I need to do to calculate the mass of calcium metal is figure out how many moles of gas are at these conditions. So I've listed my PV equals nRT conditions on the left. So we are at normal classroom conditions, so we've got 1 atmosphere of pressure. The volume is 0.520 liters. That's because we want to do this in liters, not in milliliters. So I've converted this into liters. Moles is what we're looking for. R is 0.082. And the temperature, normal room temperature is about 22 degrees. So if you add that to 273, we get 295 Kelvin. So first we're going to do is put this into our PV equals nRT equation and solve for moles. So we have 1 ATM times our volume in liters. N is the thing we're looking for, and our temperature. So if we multiply what's on the left, we get 0.52. And we multiply the numbers on the right, so 0.082 times 295, we get 24.19. We'll divide by 24.19 on each side, and we'll get N equals 0.0215 moles of H2. So this is how much H2 gas we have. From here, we can use a multimole ratio to figure out how many moles of calcium we have, or how many moles of calcium we would need to create this much gas, and then we can convert that into grams. So 0.0215 moles of H2 times our multimole ratio, so 1 mole of calcium. It's a 1-to-1 ratio. So for every 1 mole of hydrogen gas, we require 1 mole of calcium. And then I'm going to put my conversion to grams. So there's 40 grams of calcium in 1 mole. This gets us a total weight of 0.86 grams of calcium. So that's how much calcium metal that we need. The second part of the question says, what volume of 3 molar HCl is required for this reaction? So again, we'll start with our moles of H2. This time, we're going to convert into moles of HCl. So there's 2 moles of HCl for every 1 mole of H2 gas produced. And then we're going to use the molarity. So 3 molar can be written as 3 moles per liter. And we can use this as another conversion factor in our dimensional analysis problem, or you can use this as a proportion. So 3 moles over a liter is equal to however many moles you calculate from here over X liters. It's the way you can set it up as a proportion. But in the dimensional analysis problem, we can just flip it upside down because we need our moles of HCl to cancel. So we'll put X liters. So we'll put 1 liter on the top over 3 moles of HCl. And so we're going to do 0.215 times 2 divided by 3 for a volume of 0.0143 liters, which is equal to 14.3 milliliters, which should make sense to you. We weren't using huge volumes of acid in our lab, and so 14.3 seems reasonable.